Hello, everyone. Thank you for joining our webinar today. My name is Victoria Gadaychuk. I am Product Manager for Trimble Mobile Mapping System. Let me introduce my colleague, Peter Houghton, to you. Peter is Portfolio Manager for Trimble Mobile Mapping Solutions. And today, we are pleased to introduce to you Trimble Mobile Mapping Portfolio Update. In the end of the session, we plan to have a time to answer your questions. Please use the question tab to type them in. And with that, let me hand over to Peter to start with the presentation.
Thank you, Victoria, and thank you all for attending this session on our mobile mapping update. Good morning, good afternoon, good evening, wherever you are in the world. And with that, let's proceed.
Imagine a world where mobile data capture is as smooth as a Sunday drive. That's the power of the all-new Trimble MX50. It's not just a better system, it's a lightweight, easy-to-own mobile mapping solution that's completely changing the game. Installs in minutes and easily goes anywhere the road can take you. With world-class precision and total confidence. If you can see it, you can map it. Capture, process, extract, and share your data seamlessly. With intuitive workflows that keep your projects cruising at top speed. And plenty of blue sky. If you're ready to take control of your data, slash work time, and leave hassles in the dust, the Trimble MX50 is right on time and ready to roll. Let's take productivity on the road.
So, our biggest news is the MX50. Hopefully, most of you will have heard of this by now. I must say we've surprised ourselves with how much publicity we're getting, not through lack of effort, I must say. We're getting for the MX50 product. It's proving to be very popular. So we're going to give you a run through details about the MX50 and how it impacts our portfolio. So this is a picture of the MX50. You'll see mounted on a vehicle here with basically two laser scanners arranged in a butterfly configuration and a 360-degree camera, and of course GNSS and inertial-based positioning system. So the MX50 has been designed as a practical mobile mapping system for asset management, mapping, and road maintenance. So we're building on our experience both in mobile mapping and also in Trimble laser scanning here, bringing the two things together along with a panoramic camera and a Planix GNSS IMU unit. We believe that this will represent a cost-effective solution to end users and open the doors of mobile mapping to more users who hopefully are going to understand that mobile mapping is really an extremely productive way of surveying these days. So an overview of the system. For those of you that are familiar with our MX9 product, you will see some similarities. So the system itself, we have two Trimble manufactured laser profilers measuring at 480 kilohertz and with a scan speed each of 120 scans per second. We have a spherical camera and a Planix AP20 GNSS inertial unit. GAMS is offered as standard. That's the 2 antenna system for heading aiding, GNSS heading aiding. And there's a single cable connection between the sensor itself and the control unit which sits in the vehicle. So we also have our power unit, a control unit inside the vehicle, and the system is supplied with a roof rack. The only accessory that isn't supplied as standard with the system is a DMI, a distance measuring instrument that fits to the wheel of a vehicle. So this is an optional accessory. So let's have a look how it all fits together. Outside the vehicle, we have our roof rack, which is supplied as part of the system. We have the MX50 sensor head itself with our lasers, 360-degree camera, and GNSS IMU. We have the secondary antenna system, or GAMS as it's known, for aiding with heading. And then there is an optional DMI that can be fitted to the vehicle's wheel. Inside the vehicle, we always recommend that a secondary battery is installed in the vehicle. The main reason for doing that is just to give some insurance that we don't run down the main battery on the vehicle through, prolonged use, particularly on perhaps an older vehicle where the primary battery isn't in its best condition, let's say. That secondary battery would then be connected to the power unit of the MX50, which is connected to our control unit. The control unit then connects to the sensor head, so data and power being connected to the sensor head. And then inside the vehicle, from the control unit, we create a Wi-Fi hotspot. And that Wi-Fi hotspot allows the user to connect to the system using simply a web browser, and the software is inside the operating software, which is called TMI, is inside the MX50, and once you're connected with a web browser, you're able to operate the system. Some specifications of the MX50. I hate slides like this, to be honest. They're just a list of features and numbers. So I'm just going to point out the main things for you on here. So we have 2 laser scanners and a Ladybug camera. We have a Planix AP20. And the sensor weight is 23 kilograms. Which is significantly less than previous systems. Measurement rate, 480 kilohertz for each laser. Scan speed, 120 seconds for each laser. And maximum range of 80 meters. So this is a hard cutoff at 80 meters. It doesn't mean this is our expected maximum range. It means that the system will perform to 80 meters and it cuts off at 80 meters. The system is operated using our TMI software. This is common with the MX7 and the MX9. This allows the user to operate the system. It's a very simple interface. The data recorded in using our system is directly readable in Trimble Business Center once the data is recorded, and the data is, of course, recorded in a compressed format. I want to say a little bit more about our portfolio of mobile mapping products. So we now have a portfolio of products ranging from the MX9, which remains the flagship product in our fleet. We now have the MX50 in the mid-range of our portfolio, and then the MX7 for those people that are interested primarily in capturing images. So the MX50 completes our mobile mapping product offering and offers a accurate point cloud and complementary imagery at a price that we believe drives a compelling return on investment. So another view of our portfolio. So at a high level, the MX9 is really focused at high-end surveying and engineering applications. The MX50, asset management and mapping applications, and the MX7 at imaging only kind of street view, object inspection kind of applications. I want to highlight to you the right-hand side of this table, and if you look at the software comparison between the products, it's the same. So the workflow is the same across our portfolio. We're using the same software products, and this has an advantage that perhaps somebody that's already an MX7 owner or an MX9 owner can add an MX50 to the fleet, and the workflow is exactly the same for all products in our portfolio. So some of the characteristics and applications of the MX50, I mentioned to you things like the measurement rate and the scan speed. What does that actually mean? It means that we're collecting a little bit less than a million points per second. So 1 million points per second, which is significantly a huge increase on the MX2, which was our previous kind of mid-portfolio product. It's very accurate. It's limited to 80 meters, but we believe the kind of applications that will be interesting for MX50 use are DOTs and highway authorities, both for locating street assets, but also for measuring the road surface itself, for utility companies for asset extraction and inspection, cities and municipalities, again for asset extraction and modeling, and then other transportation applications such as large load and vegetation clearance kind of evaluations. Also, we're seeing interest much more now, I would say, in the last year, and becoming more and more every day, in using mobile mapping for general topographic surveys. Mobile mapping is so undeniably productive compared with other surveying techniques that even for mid-range survey, the mobile mapping is becoming of interest, right? Because it's just so productive. The workflow. We pride ourselves in Trimble that we're not just throwing hardware over the fence to people, but we are providing a complete field to finish solution. That's very important to us, and we continue to develop our software capabilities to optimize the workflow for mobile mapping, and will continue to do so. So if we look at we think of 4 stages in the mobile mapping workflow, and the MX50 is no different here. We think about capture, processing the data, extracting objects from the data, and then sharing the data. Sharing the data is, again, increasingly important, I believe. The data is so rich that you obtain with mobile mapping data. The best way to justify capturing mobile mapping data is to understand the value of this rich data. And if you really understand the value of the data, you'll soon come to the conclusion that the best thing to do is share the data widely across an organization or across a project, so that all stakeholders can gain knowledge from this rich data. In terms of the specifically Trimble workflow, so we have TMI as our capture software. TBC is where you would do most of the processing. So this talks about things like processing the trajectory, doing registration, generating point clouds, etc. And then from an extraction point of view, there's a choice of either continuing in TBC or going to our TMX product. And then for sharing the data, we have our TMX publisher platform. So a little bit more detail on the workflow. Capturing, so I mentioned many times already, we have TMI. Processing the data in TBC, we can now do trajectory processing. We can generate the point clouds. We can do registration to control points or run to run. We can colorize the point cloud. We can blur images, and we can export the data. And then moving on to extraction, really, I would say there are 2 choices in our workflow here. For surveying and engineering deliverables, a user can continue in TBC and has the opportunity to create ground models, extract features, some line features, point features, or generate profiles, cross sections, so more focused at those engineering kind of deliverables. Or if the workflow requires more of a leaning towards asset management and GIS, the user can go into Trimble MX, which supports a much more GIS focused workflow and provides a very nice environment for extracting assets and associated kind of attribute data. And then the data can be published in Trimble MX Publisher and shared across an organization or project. So capture, process, extract, and share. This is the Trimble way. Capture, process, extract, and share. Capture. So here we have a little screenshot and video showing the capture software. So we focused here on simplicity, and an operator doesn't need a huge amount of training to operate the system. Operator can very quickly, at the press of a button, change between navigation information, image information, or indeed point cloud information, and the trajectory is recorded there on the map display. And here you'll see a waterfall view of the point cloud as it's captured. And then once an operator is happy with the system, gets to the right location to start recording data, they just press the big green button in the bottom right hand corner. Now we're recording a run, so images, laser data, position data is all now being recorded and will continue to be recorded until the operator hits what is now a big red button in the bottom right hand corner, and that will stop the run. Processing the data, as mentioned here, we're in Trimble Business Center. And this is the result of following all the basic steps in Trimble Business Center. You'll see some colored trajectories on the screen. These are the different runs that have been processed. This is a project of a road junction. You see the point cloud has been processed and colorized, registered, and this is MX50 data. So you'll see the kind of quality of the data we're getting from an MX50 once it's processed in Trimble Business Center. Then, as mentioned, we can extract in TMX. This is our TMX product. Again, showing the same project and data being extracted here in terms of the road sign there. And then we can share the data in Publisher. And in fact, if you go to the MX50 part of the Trimble website, you have an opportunity to look at some MX50 data that we are sharing publicly from one of our testing locations, where you can experience MX50 data simply in a web browser. So I mentioned quite quickly that we are using Trimble LiDAR for the first time in the MX50 system. So bringing together our knowledge from mobile mapping and our knowledge from building terrestrial laser scanners, we have now launched the profilers that are used on the MX50. This allows us to much better support our customers. So if something should go wrong in the future, a customer needs support with a laser scanner, then it's much easier for us to support our own technology than it is if we have to deal with a third party. So provides us with a much simpler, logistically speaking, support capability. Also, the data quality is excellent, so why wouldn't we use our own laser scanner? And it is providing dense enough data without being overkill and not too much. So it's kind of achieving the right balance of functionality against data overkill. So I'm going to back that up now by showing you some MX50 data and some of the results that we've been getting from our review of the MX50. So firstly, I mentioned that we have an 80-meter range of the profiler. This means that we get a very clean, approximately 160-meter data corridor, usually 80 meters either side of the trajectory is by far weighing enough the area of interest for a mobile mapping customer. And it also means we don't get all those long range positions in the distance, which are subject to greater error because they're much further away, and any heading error or angular error will translate into those far off positions. So we get this very clean data corridor, and I'd say it's almost an advantage seeing this kind of very clean corridor. This is a view of some data in TBC of a typical dual carriageway. Here's some data of a street scene in Germany, colorized point cloud. As you see, data looks very nice. That's not a photograph, by the way. That is the point cloud. This is another view of some data, colorized point cloud, a drive-through that I was playing with in TBC. This particular project, actually, I'm not sure if it's uploaded yet, but this is going to be the data set that we put on our website as a download that you can play with in TBC. It's actually in Colorado, this particular data set. Here, I'd like to show you, if you look at the top part of the screen, there are some runs running left to right here. There are actually 4 runs of the same location, running backwards, and forwards. And you'll see the yellow rectangle is a cutting plane. So I've cut through these 4 runs, and these are displayed. I'm going to zoom in on the road surface. So we're getting a cross-sectional view through that cutting plane of the road surface. And as I said, there are 4 independent runs here. So 4 repeat runs, if you like, and you'll see the data consistency on the road surface. So all those points are kind of random noise on the road surface, if you like, between the 4 runs. There's no biases you'll notice in the data. It's all fairly random. And if I measure the extremities of the noise across those 4 runs, you'll see we're getting, in the worst case, by the way, not the best case, in the worst case, we're seeing repeatability at the extremities of 9 millimeters in the vertical. So that is the kind of quality of data we're seeing. So the MX50 data is producing very clean and low noise data. We believe this, particularly on the road surface, will be of interest to those who are undertaking road and highway applications, perhaps where they want to build a DTM of a road surface. What faster way can there be than driving it in a car and producing a very, very clean point cloud from which you can generate cross sections and profiles? But at the same time, the system could also be used for, of course, all the asset management tasks along that road corridor. So we've seen that the MX50 data is clear, it's precise, it can be used for survey, and it can be used for GIS. We've also introduced some new things for Trimble Business Center for the MX50. So the version of Trimble Business Center is version 551. And we've introduced trajectory processing, obviously point cloud generation to support the MX50's data formats. And we've introduced image blurring. So you can now process your trajectories from within inside TBC. It does still require POSPAC to be installed on the computer, and it requires a POSPAC license, but it means that you can run your trajectory processing from within TBC without having to leave TBC. So it simplifies the workflow, but does require a POSPAC license. All the QA/QC reports that were previously available in POSPAC are also available in TBC, so you're able to fully quality control your trajectory processing. Image blurring has become particularly important, especially in the EU. If you want to share mobile mapping data over the internet with the public, it's very important to follow the GDPR regulations, which require anonymization of vehicles and people's faces in particular. So we've introduced this feature that when you come to the stage of data export, you can check a box and request that vehicles and people are blurred in the exported images. This is a completely automated process. Going to look now at a little project we did. I think I've shown it in some of the previous slides. Close to our office in Germany, where the MX50 is built, we have a quite complex road junction at a place called Jordanbad. So we collected some data here. I think there are 11 runs. You'll see the different colors. It's kind of a roundabout with several, half a dozen or more approach roads, and then the blue, light blue color in the center is actually a flyover or a bridge that goes over the main roundabout structure. So quite a complicated road intersection. It's approximately 1,300 meters by 570 meters, the kind of area we're talking about here. It's on 2 levels. As I mentioned, the blue line in the middle is actually a flyover. There were 11 runs. If we add all the runs together, it comes to 5.7 kilometers. And the total fieldwork time here was 50 minutes. 50 minutes. Actually, this got me thinking to a project I did in my early days as a surveyor. In 1987, I was asked to do this survey of a similar road junction, not identical, but similar kind of size and complexity in West London. It's a very, very busy intersection, one of the busiest in Europe, I would say, and was complex to survey. We were using a total station. This survey took 2 months. So in the space of my career, we have gone from 2 months to 50 minutes. Just looking at some of the data that we computed for this project. First of all, we registered the runs together. We classified it automatically in TBC. You can do automatic classification into buildings, ground, high vegetation, posts and signs, power lines. The point cloud was classified as such, and the data was exported to TMX. This is what classified point cloud looks like. So in this particular case, you'll see it's mainly vegetation and ground. There are some road signs as well. But the automatic classification in TBC is very useful, particularly if you are interested in the ground, because it means you can switch all the other classes off and just have the ground, and it gives you a very clean starting point, for example, to build a ground model of the ground surface. just another view of the point cloud of that road intersection. Again, another view with the flyover or bridge going across the center. There are multiple runs intersecting each other here. So registration obviously was quite important. You see the quality of the data here. I mean, this almost looks like a photograph, but indeed it is the colorized point cloud. And another view of the colorized point cloud. And then this is a view on the road surface itself. This is actually going around the roundabout part of that road intersection. So the vehicle is probably traveling at 40, 50 kilometers an hour here. And you'll see the size of the grid we're getting on the road surface, around about an 8-centimeter grid pattern at that speed. You'll also note the consistency of the data on the road surface and the lack of any noise. Here I've just put a cutting plane through the bridge section. If you look in the bottom window, it's not very clear actually, but if you look at the bridge section, you'll see there's a slice through the bridge, and you can even see the substructure of the bridge in that kind of cross-sectional view. Here's just another view of a road sign. I've just cut this out as in a box to just look at this road sign. So again, there were 3 runs here, so you'd expect to see some inconsistencies between the 3 runs, but you'll see the data looks pretty clean and good agreement between the 3 runs. And if you look at the box on the right-hand side, there's this kind of side-on view of the road sign. You could actually measure the thickness of the road sign if you wanted to. Here's an overhead sign, again, just cut away in a limit box. So you see again very clearly overhead road sign, very little noise, if any noise at all. The odd spot here and there, but really nothing of any major significance. If I change the color coding to grayscale intensity rather than color coded, and then kind of zoom in on that road sign, you'll see you can almost read the road signs in the point cloud. Not quite, but almost. And then here I'm putting a horizontal cutting plane through the support structures of that road sign. So you'll see on the left-hand side, again, multiple runs there and great agreements around the pole of the road sign. And then on the other side of the trajectory, again, great agreement between the different runs. Here's a view, same project. This is showing point cloud and panoramic image overlaid. Really just want to illustrate the good overlay between the images and the point cloud here. There's a slight delay in the video here, but you can see that the overlay, once they come together between the image and the point cloud, is very good. and the data in Trimble MX. So again, here's the data now exported to MX software. So now we're working in more of a image-based user interface with kind of the point cloud more in the background. Another view of the data in 3D in TMX, and then just some examples of the kind of thing we can do with MX50 data in Trimble MX software. There are a variety of manual and semi-automated methods of extracting data in Trimble MX software. What I'm running here is a routine to detect poles. So I'm just creating an area of interest in the top window. I'm basically going to tell the software, can you please go and find poles in that area of interest. So the routine is started, and you will see in the map window at the top, the icons start to appear in the map display as poles are detected. Routine is now complete. So now I'm going to do a kind of virtual drive-through in the images at the bottom, and you'll see the icons that appeared on the map now also appear in the image at the pole locations. So in this case, it's lamp posts. Just another example. Impossible to show you all the tools here in this, but oh, beg your pardon. Again, just wanted to show you some examples. This is a method of measuring cables, overhead cables. It's called catenary measurement. So I select the tool used to measure this. And then first of all, I have to identify the ground surface. So I click on the ground. And then I go to the first pole, click on where the cable intersects with the pole, move to the second pole, again, click where they intersect, and then I can measure the catenary distance and the height above ground of that cable. A little bit more about the data fidelity and accuracy of the MX50. So one test we did, which I stole from somebody else that once demonstrated a LiDAR system to me, was put some objects in the road and drive over them. So you'll see here, there's a piece of cardboard with some bits of foam. There's like a carpet tile and a concrete block. So put these objects in the road, drove over them. You'll see what they look like in the point cloud. Very clear, very clean. You'll see not only can you see the objects very clearly, but you can actually see the block paving pattern in the point cloud. In this case, we were actually able to measure the thickness of the carpet tile. This is for those customers that maybe are MX9 customers or previously were MX2 customers and are interested in data comparison between the various systems. So the MX2 here, MX2 no longer exists as a saleable product, but it's really in there as a reference point for you to see the comparison between data collected with an MX50 and MX9 and an MX2. So this is a street scene. You can see the difference in data density there between the three systems. And then here's a similar comparison on road surface itself. So you'll see in terms of the step changing data quality and density compared to the MX2. With that, I thank you for your time. I'll be back again in a few minutes to help with answering questions, but I'm going to hand over to Victoria, who's very kindly going to say a few words about where to find out more information.
Thank you, Peter. And exactly about that, we encourage you to visit our new mobile mapping solution webpage or updated webpage. There you will find the overview and information about our portfolio and all systems, but not only that, you will also find the product guide there that is showing the differences between products in our portfolio today to help you to make the right choice for your projects. The next one, please. And obviously, there is a Trimble MX50 specific web page where you can find technical specification of the system. You will find some educational materials there. You will find the links for the video materials there and much, much more. We really encourage you to visit it and learn more about Trimble MX50, combining with the information you just received during this webinar. And then the next one, please. There are some resources to get the news and updates from Trimble Mobile Mapping team. We are maintaining Trimble Mobile Mapping Gazette, and here you can see the link to subscribe to it. You can also get this link from the geospatial.trimble.com, from the MX50 web page and the solution web page that I already mentioned. You will get the latest user stories, updates about the product, and learn more what Trimble is doing, and also get the invitation to the webinars we are driving. On Trimble Geospatial blog, there is also the good chance to get the latest interesting mobile mapping use cases related information from around the world. On Trimble Mobile Mapping YouTube channel, you will see the various videos that are not only showing our systems in action, but also help you learn our solutions in a better way, in a simple way, and review videos with the frequency you need. There are also some materials about data processing that explain how to use MX50 data, but also data that is coming from other systems in our software solutions. The latest link I would like to talk to you about, it's a link how to follow Trimble Mobile Mapping webinars. Stay tuned. We'll be announcing very soon the TBC Power Hour, where we will be talking about processing of Trimble MX50 data in Trimble Business Center software. With that, I think we are done, and we do have a time to answer your questions. And I can see we have quite a lot of them. So starting with the first one, can the system support other camera options? For instance, a higher resolution camera. Peter, would you like to answer this one?
The answer is no and yes. So we don't have currently a Trimble solution that you can add additional high resolution cameras, but we have a partner company that we work with called Horus, based in the Netherlands, that have a solution for 3 high resolution cameras, and this will work with the MX50.
Thank you, Peter. The next question we have, if I understand correctly, in the TMI, when capturing the data, if we look at the point cloud data, we see it from an above point of view, right? Do we see the two laser scanners separately like with MX9 data? Maybe I can take this one. And indeed, in TMI, as shown by Peter on the short video, indeed, we are looking at the point cloud from the top view, but there is an option to visualize two lasers separately in a similar way is MX9. The only one difference is that we don't visualize the profile view with the MX50 at the moment, but you can switch between left and right laser to make sure that both are operating properly and capturing the details as expected.
Maybe I can take the next question, Victoria, to give you a chance to catch up. The next question says, when you say the range is 80 meters, does it mean that beyond that distance the data is not collected? The answer to that is yes, you're quite correct. So we collect data to 80 meters and beyond 80 meters, even if it was theoretically measurable, we don't record it.
Thank you. Has the MX50 even been or can it be mounted on a survey board? Thank you, that's a good question. We have to say that we didn't test that, although we have customers who mounted MX9, for instance, on the survey board that will give you some understanding on the weight and dimensions. MX50 is lighter system. It's almost 10 kilos less for the sensor head. And regarding the IMU, for instance, we also had MX2 users using AP20 installing system on the survey board. But did we test MX50 on the survey board? No, we didn't. We didn't do it yet.
Next question, Victoria, is the webinar available to view at a later date? The answer is yes, we are recording it and you will all receive a link which you can pass on to colleagues if you would like to.
Yeah. Can the wire heights be measured in TBC for any point cloud surface, or that's specific to mobile mapping?
Well, actually, the example we showed, just to be clear, the example we showed in the presentation was actually in TMX, not in TBC, but you can do similar things in TBC, and can you do with any point cloud, not just mobile mapping? The answer is yes.
All right. There are the questions about the pricing, and we just ask you to contact your local Trimble sales representative, and I'm pretty sure that the team will be happy to share all necessary details with you. Who is the LiDAR sensor manufacturer? That's a good one. Thank you. Peter, would you like to say something about that?
The LiDAR sensor manufacturer is Trimble. So
can this be you?
Sorry,
go ahead.
Yeah, so the LiDAR unit that we're using is designed and built in Germany at Trimble facilities. Yeah, don't know what else to say.
Can this be used to scan at night to avoid traffic?
The answer is yes, LiDAR works at night, but please be aware cameras aren't so good at night because they need light. So probably you won't get great performance out of the cameras at night, but the LiDAR itself would be fine.
Thank you. Is there a payment condition indexing module available, or do you know if the point cloud can be imported to the third-party PCI software? The answer, would you like to answer, Peter, or shall I go ahead?
You go ahead.
So in Trimble Business Center, we don't have the that module available yet, or that functionality available yet for MX50 data, for mobile mapping data. But if you wish to use third-party software for that applications and the needs, and you have your preferable tools to work with, then it's definitely possible to export clean and prepared surface point cloud, the region or class, to process point cloud in the other software as a next step and get the indexing available in the software that provides us capabilities today. The next one.
Next question, maybe I'll go ahead, Victoria.
Will the MX50 be able to operate at temperatures above 40 degrees, temperature easily attainable in my location?
If we go with the specs of the system, I think probably the camera is the one component which is spec'd. I think is at 40 degrees, right, Victoria?
Up.
Maximum.
Yes.
So from a camera point of view, the limit is kind of 40 degrees. Do we have customers operating similar systems such as our MX9 system, which basically is kind of very similar? Yes, we have plenty of customers in the Middle East who do this regularly, but yeah, we can't guarantee the camera above 40 degrees.
Thank you. Would atmospheric conditions such as ash, haze, or smoke affect the LiDAR data? And the answer is it might affect the LiDAR data, but we do have filtering capabilities in our Trimble Business Center software to help clean the data if there was any atmospheric conditions influenced it. What AU is in MX50? Peter, would you like to take this one?
Yeah, I think we said already in the presentation, it's an Planix AP20 product that we've used. It's the same product we used in the MX2, so we're very familiar with it and very happy with its performance.
Thank you. Can you map roadway tunnels with no GNSS coverage? Maybe I can take this one.
Yeah.
So with the mobile mapping system, you need to start your mission having GNSS signal. So, and if in your way there are tunnels later on, yes, data can be captured. So we will scan the tunnels. You have to be aware that you might need to do some more work to achieve a higher accuracy in this environment, in this type of the environment under these conditions. But definitely, yeah, you can scan data in tunnels. Why not? In road surface material type and condition automated in Trimble. Is road surface material type and condition automated in Trimble software?
Unfortunately, no, not at this point. So we don't do that at the moment. We understand that artificial intelligence, particularly relating to imagery, is coming along, and there are probably third parties that can do that already. But we don't currently have that in our software, but it's a good idea.
Yeah. Then your brochure says that bright color vehicles should be avoided when mounting the sensor. Should white ones trucks be avoided too?
That's a good question. I can't think of a great answer for it. Yeah, I mean, we can get reflections of bright surfaces that you want to try and avoid if possible, but yeah, plenty of people use white vans and trucks. I don't think it's a major issue. Our choice for our own vehicle is we choose grey because it's a kind of neutral neutral color, but yeah, it can potentially cause some issues, but I don't expect them to be major.
Let us check the documentation you're referring to, and let us also see if we can provide a better and clear answer through the documents. Can this data be imported into RealWorks to couple a mobile scan with land-based scanners such as TX8?
I think the answer is yes, or you can do it in TBC, or you can do it in any software that supports basically point clouds and coordinate systems. We can export the mobile mapping point cloud as a LAS file, so it could really be brought together in any software that supports LAS format.
Yep, thank you. Just let me, we got also several questions in Spanish, and I'm sorry, I don't speak Spanish, so just translating questions on the way. And one of them was about the pricing, and as said, you have to contact your Trimble sales representative to get those details. And yeah, the second one in Spanish also is about the pricing. And yeah, answer is the same as for previous one.
Yeah, if you contact either your local Trimble sales guy or your local Trimble geospatial dealer, they'll be able to help you with that.
Looks
so
like
that,
we answered. Yeah.
Yeah, no. So thank you, Victoria. Lots of interesting questions. We thank you for your questions, and I think on behalf of Victoria and I thank you for attending this webinar, and please look out for our forthcoming webinars. Thank you.
Thank you. Bye.